So what we're going to do today is go over the practice tests. Now, the way I do tests, your practice tests are very similar to the real thing. Basically, what I do is I just modify the practice test, put in different numbers, maybe a different word problem. They're basically the same length. And the problems are very, very similar. Now, don't forget to download the take-home test problem, only one problem, print it out, do it. It's a long problem, though, so that's why I'm giving you a whole week to do it. So I'd recommend you download it sooner than later and start going through the assumptions and figuring out which ones you need, which ones you don't need. Okay? That's located on, I sent you an email out on that, but it's located on files, test related. You'll see it. Okay. Convert these numbers to scientific notation. Now, to me, these are very awkward numbers, except for C. But A and B, I would recommend you, if you get that as an answer on your calculator, definitely convert it to scientific notation. C, I'd recommend leaving it as 100. Okay, so and whenever you convert to scientific notation or from scientific notation back to a kind of a normal number, make sure you maintain the number of sig figs, because that's going to come into play on C. Okay, so now how many sig figs does A have? So your scientific notation has to have 2 also. Now C can be tricky. How many sig figs does C have? 1 sig fig. So your scientific notation has to have 1 also. All right. Sig figs. Okay, we've got a trailing 0 on A. That means if there's a decimal point, it counts, and there is a decimal point. So we've got 1, 2, 3, 4, 5, 6. Mid zeros, they all always count. So we've got 5. Trailing zeros, no decimal point. That means they don't count. So it's 1. By the way, the average, this is last semester's test over the summer. The average grade on this was an 88, just FYI. Okay, round to 3 sig figs. Okay, to go to the 4th place. If it's 5 or greater, it kicks the 3rd place up by 1. Go to the 4th place. 0 to 4, you drop it. Now, C is tricky. Why is C tricky? How many sig figs does that have? 7, right. Okay, and we want to round that down to 3. Scientific notation is our friend. Yes. That's the only way to do this problem. So you've got, um, okay, does everyone understand why we're forced to use scientific notation on C? Okay, so this has got five and what, 3, 6, 8. You could also do, either one of those is acceptable. So in these problems, I would split the 5 points between a numerical correct answer and also sig fig wise. Okay, conversions. For those of you who have come in after I mentioned this, I photocopied off the latest conversion sheet. This is the same one you're going to be using for your tests. Okay, so we're going from kilometers to feet. Okay, we have meters to feet. So if we go from kilometers to meters, then we can go to feet. So it's a two-step process. Okay, and there is Okay. And we're looking at 2 sig figs, so it's going to be 1.5. Feet. Okay, years to minutes. This is a very straightforward. We're going to go, there's 2 ways to go. We can go years to weeks or years to 365 days, either way. You get a tiny bit different because of the leap year thing. So let's do 52. Okay, so we've got ounces. So we can go from ounces to pound, pound to grams, grams to milligrams. And we're looking at 4 sig figs. What? It's by definition though, 16 ounces to a pound. Is that where you're going with it? Yeah, by definition. So it's infinite sig figs. Okay, so we're going to do some word problems here now. Now, the interesting word problem is this last one. This is a true story. I'm going to talk to you about this when I get to it. It's a pretty cool little story. I mean, I should say clever. Okay. Gas in Canada costs $1. Let's see. Let's wait on that. Okay, we have money per liter, so we need to get gallons to liters. Okay, so now it's in liters. Now we can use the dollar per liter to get our money out. Now, when working with dollars, just as a general rule in most classes, in this class this applies, always have cents on the dollar, regardless of the sig figs. I mean, this happens to work out. It's 4 sig figs, but if this was just 12 gallons, for example, which would mean that that should be 64. You still leave it as the dot 54 because it's money. Okay. All right. So this is a fraction problem. 1 for 3 minutes. Yeah. Now just go to, and I've never purchased gas in California or in Canada, so I don't know if they have that many decimal places at the pump. I don't know. I just kind of invented this problem. Okay, so person blinks their eyes in the average of once every 3 minutes. I blink my eyes probably once every 15 seconds. But there's a statistic out there that's 1 every 3 minutes. Okay, so so the given is going to be you could do this a couple different ways. You could do it 1 per 3, or you just say 3. So let's just start with, instead of the fraction, let's just start with the 3 minutes. Okay, so now we need to go to, if we're doing this, if you blink once in 3 minutes, how many 3 minutes are in a year? Basically, where we're going with this. So we need to go minutes, hours, da 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 da. Okay, so if we follow this logic, we end up with what? Crossing off all the unit cancellation. What do we end up with? We end up with number of blinks. No, we end up with years. So that's not a good approach because the units don't end up being blinks per year. So we need to, blinks need to come into play there. And using this process, our units don't give us blinks, it gives us years. And that process is not going to work. What can we use to start with that has blinks in it? Yeah. Yeah, let's do a fraction then. So only instead of 3 minutes per blink, 1 blink for 3 minutes, because that'll put the blinks on top. Now when you're starting with a fraction, that means you got to end with a fraction. Excuse me. So we're going to end up with blinks per year. So we have 2 problems here now. So we need to convert the minutes to years. That's one of them. Okay, so we have So everything cancels except for blinks per year. Now, the important thing on this is, the way we first started, when we're all said and done, the units didn't come out right. I'm not talking about numbers, just the units themselves didn't come out right. So that means our process had to be modified. Because our units have got to come out for what we need to work the problem. Otherwise, the setup won't be right. All those conversions were fine. It's just they weren't used in the right way. And we're looking at 3 sig figs. So 1.75 blinks per year. Okay. On this last problem, during World War II, there was a practice that people would remove some of the gold of a US coin, but not enough to not be recognized as a US gold coin. My dad was in World War II, and this is a true story. The natives there in Northern Africa is restarted. Egypt, Angola, not Angola, Libya. I think those are the 2 main countries. The people would go buy a gold coin and then buff off the gold, but not enough so that it was still recognized as a gold coin, and then go trade it back in for $20. And they would keep the gold dust. And it was approximately a gram of gold dust, because gold is pretty heavy. Okay, so the question is, how much money did the government lose, assuming all the minted coins were used in Africa? Assuming it's $17.98 per ounce. So the part that a lot of people messed up on is, how much gold are we figuring out here? Are we figuring out 30.0926 grams or 1 gram? 1 gram. 1 gram. So we have 1 gram, and we had 450. Okay, so this will tell us how many grams of gold. Now we need to figure out how many ounces of gold. And we can use the $17.98 dollars per ounce. Okay, so you need to go from grams to ounces. Well, we can go grams to pound. And then that'll give us and once we have ounces, we can use our Now, the second one there, 1 gram per coin has to be there because the units have got to cancel. So that has to be there, even though it's 1/1. And we're looking at 4. So the United States lost $28,000 by this practice. And that's assuming, of course, every single minted gold coin was done with this practice. But don't forget they had other gold coins besides $20. They had a 50 and 100 and stuff. They did it to all of them. So but anyway, I thought this was a real interesting problem when it's real, and it's kind of interesting. Okay, so that's what I wanted to do today is go over the tests. When I do test the points, I want you to pay attention to the points because they will reflect how much you're going to have to do for the problem. So if it's 5 versus 20, the 20-pointer are going to require more work than the 5-pointer. And that's just FYI. Okay. All right. Are there any questions about Lions Club? Yeah. By doing the calculation. Okay, and there was another question. Oh, did I put a? Oh, yes, you're absolutely right. Instead of a comma, I put a decimal point. So that means we have to multiply. So it's going to be 7. Yeah. So $28 million. It's because gold is worth a lot. Right. Okay, that's what I wanted to cover today. So that's the conclusion of Unit 1. Now, Unit 2, we're going to start on Friday. That's going to, you're actually going to get into some chemistry on Friday. Talk about the periodic table and electrons, protons, and neutrons, and it's more of a regular chemistry class. And everyone accuses me of teaching math class at the beginning, but it's just the way it is. So, all right. Any other questions? Okay, so yeah, that looks fine. Yeah. So what, curiously, what did that cost you? Really? That's awfully nice for $5. And you got the little thing there, the yeah, my parents' Bible used to have those. There's like 5 of them. keep track of everything.
Yeah.
That's the only place I've seen those is in a Bible and lab notebooks. No, it's fine. It's fine. And you have a lot of room in there too. Oh, that's fine. Okay, let me end the recording. Otherwise, we're gonna be on